So our lesson for today is on other types of inequalities. This is section 8 for chapter 1. It is the last section of our chapter, so if you guys would open up your books to page 140, we'll get this one started. Now the inequalities in this section are going to be a little bit bigger than the ones that we had in section 7. They're going to be some of them the compound or the double inequalities. You've solved some of them in the past in your algebra classes. And the solutions then are going to come in intervals of numbers rather than a simple, x is greater than 5 or x is less than or equal to 2 or something of that sort. So there's a little bit more work involved. We're going to have to figure out the places where those intervals occur, so beginning and endings of intervals, and do some testing with those intervals to figure out where our solutions in fact are going to be. So the numbers that will be those stop and starts to our intervals are called key terms. They are zeros for our polynomial. So there's a variety of ways in which we're going to find those zeros. They're going to look familiar with information or skills that we've done in our previous sections. So why don't we get started on our first kind. So if we have an inequality like this one, you can see you have more or less a quadratic in there. And if we're going to come up with the zeros so that we can establish or find our intervals, generally anytime you see something like this, it's factorable. If it weren't easily factorable, you could use quadratic formula to find those numbers or solutions. This one, though, is an easy one. I think you guys, in looking at this, can all find an x minus 5 and an x plus 4. So there are two zeros for this polynomial. We have one zero at 5 and one zero at negative 4. Now, what do we do with them? Well, we're going to need to figure out, are our solutions going to be in between them, under them, over them, whatever. Here's how you're going to be able to figure that out. Okay, so what I do is I just make a work field. And negative 4 is the smaller of the two, so I put that on the left, and 5 is the bigger one, so that one's sitting on the right. And I need to check. I need to check these intervals. I need to check under negative 4. I need to check in between negative 4 and 5, and I also need to check above 5. You can pick any number you wish to use as your testing value. If a value, for example, under negative 4 tests out as true, every value under negative 4 will test out as true. So you don't have to do a million of them, you just have to pick one. So my test values that I'm going to choose, and you wouldn't have to pick the same ones that I do, but I'm just going to go with a negative 5. In the center here, I'm going to test 0. And on the upper end above the 5, I'm just going to go with a 6. I like zeros, by the way. Whenever 0 falls, or the interval that 0 falls in between, that's just the easiest one to calculate with. So it doesn't necessarily have to be a certain distance from the numbers. You can pick any digit truly in the interval you want. So like in that middle interval, I'm going with 0. All right, so here's what you do. Put negative 5 in for your x's. Solve. $30 minus 20, we're looking at 10. So then you ask yourself, is this a positive statement or a negative or a false statement, or is not positive or negative, true or false? This one is not true. 10 is not less than 0. So that interval of less than 4 will not have solutions there. Okay, now we're going to test the 0. So 0 squared minus 0 minus 20 less than 0. So, whoops, that's a 20. So negative 20 less than 0, that is true. Okay, negative numbers are always smaller than 0. So this space, or this interval between negative 4 and 5, is where we would find solutions. Above the 5, so using my 6 as my test number, I'm going to have 6 squared minus 6 minus 20 is less than 0. Do your math. So 30 minus 20 again gives us a 10 less than 0. Again, that is a no. So we know that when we give answers to inequalities, since it's not a set number, it's generally a grouping of numbers or intervals of numbers, we graph our solutions on number lines. So with -4 and 5 marked, you need to tell me or show me on here that our solutions lie in between those two numbers. Our less than symbol in the problem shows me that it's not going to include the -4 or 5 themselves. So remember from our last section, that means that we will graph with the parenthesis rather than the hard bracket. And then you just shade in between them to show that all of these numbers in here are in our solution set. We also are going to need to indicate our answer in what's called interval notation. So we have to state the answer with numbers as well. So -4 to 5 would be our solution set in interval notation. Okay? Let's take a look at another one. If we're going to solve this inequality, first thing you're going to want to do is group everything together on the left and have a 0 on the right-hand side. So just like solving quadratics, move everything together. Notice that in this polynomial, we do have a 4-term or a third-degree polynomial. These are generally the ones that you use that grouping technique on. So I'm going to chop mine in half and focus on the halves. That front half, I can pull an x squared out of everything. And if I do, I'm left with a 3x minus 1 in parentheses. In the back half, if I take out a -4, I will also have a 3x minus 1. So now that I have those halves factored, I can look at the halves and see if there's anything in common, which is 3x minus 1. And the remaining numbers form the second factor. Take a look at them, see if you can factor or break them some more. The 3x minus 1 is done, but x squared minus 4 is difference of perfect squares, and we can break it or factor it some more. So key terms. We're going to have 3 of them this time. We ended up with 3 factors. We have one key term of a third, another of 2, and a -2. Okay, so I have 3 numbers or 3 key terms which are going to give me, put -2 here, 1/3 is the next biggest, and 2 would be up here. I'm going to have 4 intervals or 4 fields in which to test. I need to be above, in between, and below all of these. Okay, so my test numbers. I'm going to go with a -3 here. I can use my 0 in between this one. I'm going to go with a +1 and a +3. Okay, now there are a lot of steps or a lot of math between this, so make sure that you give yourself some space and room in which to do the work. I'm going to test my -3 first. So putting it into my inequality, I have 3 times -3 cubed minus -3 squared minus 12 times -3 plus 4 is greater than 0. Okay, putting that all together is simplifying. I've got -81 minus 9 plus 36 plus 4 is greater than 0. That simplifies into a -50 is greater than 0, and that's not true. So I don't have solutions in that interval underneath my -2. Okay, middle. I'm using 0 as my test point. So 0 minus 0 minus 12 times 0 is still 0, plus 4 is greater than 0. So 4 greater than 0 is what that simplifies to, and that's true. So I do have solutions in between these two numbers. My next interval, I chose the number 1 as my test value. So I have 3 times 1 cubed minus 1 squared minus 12 times 1 plus 4 is greater than 0. Ran out of room there. So 3 times 1 cubed is 3 minus 1 squared minus 12 plus 4 greater than 0. Okay, simplifying that, I'm going to get negative 6 is greater than 0. Negative numbers are not bigger than 0. No solutions in between those two. I have one final one to test. So testing 3. Okay, 3 was the number I chose that was above my 2. 3 times 3 cubed minus 3 squared minus 12 times 3 plus 4 greater than 0. Simplifying, 81 minus 9 minus 36 plus 4 greater than 0. Finishing that one out, it's looking like 40 is greater than 0, and that is true. So with my testing, I have figured out where my zones of solutions lie, so I can now move to my number line and graph them. So again, just list your key terms on here. I really don't need more numbers than that for you to fill in. Based on my inequality symbol of greater than, I'm going to use my soft parentheses again rather than the hard brackets. Okay, they'll begin just near the negative 2 and the 1/3, but not on them. So that first interval of solutions is between these two. And then starting at 2 and going forever is my other chunk of solutions. In interval notation, okay, now this one's going to be a little bit different than the first because it comes in two pieces. So first you have to state your first interval from negative 2 to 1/3. And then I also need to state my second interval of 2 to infinity. And then we use what's called a union symbol to say that the two of them together form all of our solution sets. Okay? So there's your solution graphed out and stated in interval notation. We're also going to take a look today at rational inequalities. Whenever you see that word rational, you know that you're probably going to be looking at rational expressions or fraction expressions. You're going to simplify when at all possible when you get these bigger ones, and then you're still going to have to identify zeros. But now that we're going to be working at fractions, some of our key terms are also going to be undefined values, which then focus on our denominator. All right, so let's look at an example of one of them. So if I have 4x minus 1 over x minus 6 is greater than 3, first thing I'm going to do is bring my 3 over and get a 0 on the right-hand side. Okay, now in order to simplify that, I'm looking at combining these two numbers, and I need common denominators. So I need to multiply my negative 3 by x minus 6 over x minus 6. So the first fraction, I don't have to do anything with this. But I need an x minus 6 as a denominator on the second one. Okay, so now let's do some simplifying. Negative 3 times x, negative 3 times negative 6, all over x minus 6. Oh, I better bring my greater than 0 along. Numerator simplifies a bit. So 4x minus 3x is just x. Negative 1 plus 18 is plus 17. And I simplify to this inequality. Okay, so like the previous slide said, we need to find our key terms now. You need to find numbers that are not only ones that make the expression 0, but we also find them with undefines. All right, so your zeros are going to come from your numerator. Okay, 0 on the top of a fraction makes the fraction value of 0. So I'm looking at the top at a negative 17. That's the only thing that will make this equal to 0. I now need to look for things that will make it undefined. Focus on your denominator here. A 0 in the denominator of an expression makes the expression undefined. 6 is going to do it down there. Okay, so I have two numbers, two key terms for this problem. Now the rest is similar to what we were doing before. So negative 17 and 6 form our breaks. Check your intervals. All right, so I'm just going to go with a negative 18 back here. My 0 falls in here, and I'll just choose a 7 up top. Okay, putting them into your inequality. negative 18 plus 17 over a negative 18 minus 6 greater than 0. So negative 1 over negative 24. Negative over negative is positive. Positive values are always greater than 0. So we've got a big old yes down here at the bottom. In the middle, let's test our 0. We've got 0 plus 17, 0 minus 6, 17 over negative 6. No. Negative numbers are not greater than 0. Let's test the top. I chose a 7 for right there. So 7 plus 17 over 7 minus 6 greater than 0. 24 over 1 is greater than 0. And that is true. So if we're going to graph our solution, our number line needs to have those two values on it. And it looks like we have solutions under negative 17 and over 6, so they're going to split. We will find solutions down here and up here. In interval notation, negative infinity up to negative 17, united with 6 to positive infinity. Okay, next one. All right, we're going to take a look at a couple of examples that are applications of inequality type situations. The first one on page 145, we're going to look at a revenue cost situation. This one is talking about determining an interval where a certain profit can be made. Now I think you guys understand what revenue is. Okay, a revenue, whoop, I don't want to use black, make it stand out a little bit more. Brought in. Revenue is money brought in. Okay, C in these types of models represents your cost or money paid out. Okay, profit then is when you have more revenue than you have costs. So profit is equal to the subtraction of those two. Okay, so keep that thought in mind as we're looking at this problem and trying to figure out how to set up an inequality that we can use and solve. So they've given us an expression for revenue for this situation, and they've also given us an expression for cost in this situation. They're also telling us that we have a goal that we're trying to meet or exceed for our profit. Okay, so it's going to look a little bit funky in the beginning because there's a lot of pieces to it. But let's go ahead and set up an inequality that fits this situation. So our revenue minus our cost. Revenue minus, I'm going to use this here to kind of separate it. Okay, so revenue minus cost. Can you guys see those pieces in there? We want to get at least $3,600,000. So we want the subtraction of those two things to be greater than or equal to that value. Okay, so now we simplify. We'll change colors here. Do your distributions. And now we're going to bring everything together. Okay, I'm going to put my x squared term out front. I'm going to put my 60x and my negative 12x together. So I have now a 48x. I'm also going to bring my 3,600,000 over. Joining that with my 1,800,000, I'm now at a negative 5,400,000. And that leaves me my 0 on the right. Okay, so when we put those things together and start simplifying this expression, you can see that that forms a quadratic. We need to find our solutions for this quadratic in order to be able to find a number of units, or our x, that we need to sell to get that profit. You could go ahead and play with this and try to factor it. I'm going to punt and go right to quadratic formula because I feel in the end it's going to save me some time. So negative b plus or minus the square root of b squared. All right, well, 48 squared is 2304. We're going to fill that right in. Minus 4 times a times c. Extend that all over 2 times a. All right, so get your calculators going. Start simplifying. Now, when you multiply negative 4 by negative 0.0001 by negative 5,400,000, you're going to get 2160. 2 times 0.0001 is a negative 0.0002. Okay, continuing to simplify. 2304 minus 2160 is 144. And the square root of 144 is 12. So that entire radical part reduces or simplifies to give us 12. So let's take our negative 48 plus 12 and our negative 48 minus 12 and find those numbers. Okay, so negative 48 plus 12 is negative 36. Divide it by the negative 0.0002, and we're going to get 180,000, excuse me. Doing the other one, we're going to get a negative 60 over negative 0.0002, which if you punch that in, you're going to get 300,000. So if we make in between 180,000 and 300,000 units, we will meet or exceed that profit of 3,600,000. Okay, so in interval notation, we want x's between them. One last skill. Domain is something that comes up in a lot of our lessons this year. Okay, so a domain is referencing our x values that can be used in our problem. So there's different situations where we have to throw out numbers because they make things undefined or not solvable. So if we're looking at this radical expression, okay, and it's asking us to find the domain, there's certain things that you guys already know about square roots. In order to find answers or real answers to square root problems, you need to have a positive number underneath. 0 is fine. But other than 0, if you have like a negative 1 or a negative number of the square root, then I comes into play. All right, we get imaginary roots. So if we're looking for a domain, we're trying to find findable solutions. All right, so looking at this problem, I need that expression underneath to stay 0 or above. So off to the side here, let's just state that. I want that thing to be greater than or equal to 0. I'll look at it again. I think you guys are starting to spot or notice quadratics again. If I'm looking for the x values that will keep this greater than or equal to 0, factor it to find them. For our positive 10, needing a negative 7 in the middle, we'll go with negative 5 and negative 2. So our solutions are x equals 5 and 2. So we've identified those key terms now. Now we can test them. We can figure out if our interval is going to be in between those numbers, above, below those numbers, or whatnot. Oop, I don't want a number line yet. So 2, 5 are our key terms. Let's pick a number that's under 2. I'm going with my trusty 0. Choose a number in between. Let's go 3. And above, I'll go with 6. All right, plugging 0 in. 0 squared minus 7 times 0 plus 10 greater than or equal to 0. So 10 greater than or equal to 0, that is a yes. So down here, underneath the 2, we have yes values. Let's check out the 3. So 3 squared minus 7 times 3 plus 10 greater or equal to 0. 9 minus 21 plus 10, you're going to get a negative 2 greater than or equal to 0. Not. Last checkpoint, let's use our 6. We have 6 squared minus 7 times 6 plus 10. So 36 minus 42 plus 10. And we end up with 4. 4 is greater than or equal to 0. So we have another yes. So to state our domain, the values that work, anything under 2. And because of our symbol here saying that it can equal 2, negative infinity, oops, I did my infinity sign upside down. Let's go sideways. Up to and including your 2, so use that hard bracket, along with, we can include our 5 and everything above. So there's our domain stated in interval notation. All right, do some practice problems off of 147 and 149. Do a bunch of them. It's the only way to get comfortable with how to do these test values. Pick an easy one. Try to pick one a little bit more difficult. Make sure that you come to class with questions that you have and things that you don't understand.